Hello student, this is question from class 10, chapter 14, probability, exercise 14.1. We are going to discuss here question from 21 to 25 here. So let's go to question 21. A lot consists of 144 ball pens, of which 20 are defective one and others are good ones. Nuri will buy a pen if it is a good, but will not buy if it is a defective. So the shopkeeper draws one pen at random and give it to her. What is the probability that she will buy it? So here we see Nuri will buy the pen if it is good one. So probability that she will buy the pen will be equal to probability that the pens are good one. Now let us see what are our total ball pens. So we have total pens, we have here is 144, and defective pens, it has been said that that are 20 here. So good ones will be is equal to 144 minus 20, that will be 124 here. So good pens are 124. Now Nuri will buy the pen if the pens are good ones. So probability that she will buy the pen or probability of getting good pens will be is equal to number of good pens by total pen. So good pens we found here is 124 here. So we write down 124 by total pens, that is 144. We can divide it by 4. We have 4 3 ja 12, 4 1 ja 4, and 4 3 ja 12, and 4 6 ja 24. That will be 31 by 36 here. Now let us go to the second part. She will not buy the pen. Okay, probability that she will not buy the pen if it is defective, right? So probability of getting defective pen will be is equal to number of defective pen by total pens. So we have been given there that there is 20 defective pen and total pen is 144. We divide it by 5, we get 5. We divide it by 4, we have 4 5s are, and 4 3s are 12, and 4 6 are 24. That is 5 by 36. So this was our question number 21. Let us go to our question 22 here. So we have to complete the following table, and the event is sum of 2 dice. So when we throw 2 dice, its sum is 2. What is the probability that its sum is 2? Let us go to the total probability here. So when we throw 2 dice, total probability we get is 36. If we throw 1 die, it can have 1, the other one also can have 1. If we throw first 1 die, we can have 1, and when we throw second die, it can have 2 here. So like this we have total probability, that is 36 here. So we have to write the total probability that the sum of 2 dice is 2 here. That is here, this is 1, that is 1 by 36. So we have to write the probability that the sum is 3 here. That will be 2 1 and 1 2, that is 3. So it will be 2. So it will be 2 by 36 here. Probability that the sum is 4 here will be 3 and 1 4, 2 2 4, 1 and 3 4. That is 1 2 and 3 here. That will be 3 by 36. In the same way, the sum is 5 is 4 and 1, 3 and 2, 2 and 3, 4 1 and 4. That is 1 2 3 and 4. That will be 4 by 36 here. Probability that the sum is 6 will be 5 1, 4 2, 3 3, 2 4, and 5 1 5. 1 2 3 4 5. That will be 5 by 36 here. And probability that the sum is 7 is 6 1, 5 2, 4 3, 3 4, 2 5, and 1 6. That is 1 2 3 4 5 6. It will be 6 by 36. Probability that the sum is 8 has been given. So probability the sum will be 9 will be 6 3 5 4 4, 5 and 3, 6. That is 1, 2, 3, 4. That will be 4 by 36. Probability that the sum is 10 will be 6, 4, 5, 5 and 4, 6. 1, 2, 3. That will be 3 by 36 here. Probability that the sum is 11. Here will be 6, 5 and 5, 6. That will be 2 by 36. So we have completed our table here. Now let us go to our second part. Our second part says a student argues that there are 11 possible outcomes. That the sum of two dice will be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That is 11. So therefore each of them has a probability 1 by 11. Do you agree with the argument? Justify your answer. So we do not agree with this argument as it is not equally likely outcome. So we write down, no, this argument is not correct. Why it is not correct? As the 11 sums are not equally likely. For example, getting the sum 2 is 1 by 36. Probability of getting sum is 2 by 36, not 1 by 36. Each time we throw the die, the sum of getting 4 will be 3 by 36. 5 sum we get 5 is 4 by 36. So they are not equally likely outcome. So this argument is correct. This argument is incorrect here. Now this was our question 22. Now let us go to our question 23 here. So we have been given that a game consists of tossing 1 rupee coin 3 times and noting its outcome each time. Hanif wins if all the tosses give same result. That is 3 heads or 3 tails, and lose otherwise. Calculate the probability that Hanif will lose the game. So if the tosses do not get the same result, that is 3 heads and 3 tails, so Hanif will lose the game. Let us first of all see what are our possible outcomes here. So possible outcomes here are head, 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 tail, 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 and head, head, tail, 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 head, and head, tail, head, and tail, head, tail, and it can be head, tail, tail, and it can be tail, head, head here. So possible outcome we got is 8 here. So Honey will lose the game if he does not get 3 heads and 3 tails. So number of times 3 heads and 3 tails do not occur. Here is 1, 2, 3, 4, 5, 6. That is 6. And total outcomes here is 8 here. So probability that Hanif will lose the game will be number of times 3 heads and 3 tails do not occur, that is 6, and total outcome is 8. So we divide it by 2, we have 3 by 4. So probability that Hanif will lose the game will be 3 by 4 here. Now let us go to our question 24 here. A die is thrown twice. One die is thrown twice. What is the probability that 5 will not occur either time? So now, and 5 will come at least once here. So throwing a die twice and throwing 2 dice simultaneously are treated as the same experiment. So now let us go to our chart again here. See, we have to find 5 will not occur either time. So let's see how many times the 5 occurs. Here we have this line occurs 5 here. 1, 2, 3, 4, 5, 6, and this also 7, 8, 9, 10 and 11. So number of times 5 occurs here. So first of all we have to write total outcomes. Let us write down first of all total outcomes here is 36 here, and 5 will not occur. 5 will not come at least once. That will be 11. Okay, so will come. Okay, to 5 will come at least once, that will be 11, and 5 will not occur, that is 36 minus 11, that will be is equal to 25 here. So number of times 5 occur here is 11, and number of times 5 will not occur, that is 25 here. So we have to find the probability that 5 will not come either time. So probability that 5 will not occur. So 5 will not occur will be 25 here. So that will be 25, and total outcomes is 36 here. So probability that 5 will not occur either time will be 25 by 36 here. And here the probability that 5 will come up at least once, that will be 11 here. So that will be probability, that will be 11, and total outcomes we have is 36 here. So that will be 11 by 36 here. So this was our question 24 here. Now let's go to our question 25 here. Which argument are correct and which are not correct? Give reason here. So if two coins are tossed simultaneously, there are three possible outcomes: 2 heads, 2 tails, or 1 each. Therefore, for each of these outcomes, the probability is 1 by 3. So this is incorrect argument. This is incorrect, as total outcomes here will be, when we throw toss 2 coins, will be head, that will be head, tail, head in the first coin, and tail for the second coin, tail for the first coin, and head for the third coin. So here total outcomes are 4 here. There are 4 outcomes. Therefore, probability of each of these outcome will be 1 by 4, not 1 by 3. Okay. Now here, if a die is thrown, there are 2 possible outcomes: an odd number and even number. Therefore, probability of getting an odd number and even number is 1 by 2. This is correct. This is correct argument, because possible outcomes we have here is possible outcome. Here is 1, 2, 3, 4, 5, 6, and number of odd numbers we have is 3 here. So probability of getting odd number will be 3, that is 1, 3, and 6 here. So it is 3, and total outcome is 6, that is 1 by 2. So this statement is true, this argument is correct. I hope you understood this question. Thank you.